Good morning, viewers, and welcome to my channel once again. In today's tutorial, we are going to look at polygons. Polygons is one of the easiest topics you can find in mathematics. So, when you look around, most of the shapes you see form polygons. So, for instance, if you're in a room, let's say in a classroom, you see doors, you see books, you see windows, and what have you. All these shapes form polygons. So we say that we can see or can get polygons in our daily lives. So they are around us. So looking at what we mentioned, there is a picture over here. Yes. So if you look at this tortoise or turtle, you realize that at the back has so many designs, and these shapes are all polygons with their respective sides. So we can find polygons here. And when you come to a classroom like this, there are so many shapes in this classroom. The door has its own shape. The the window over here has its own shape, which forms a polygon. The table, the tables, the books on the tables, all these form some shapes, and all these are polygons. Now, let's continue. A polygon is one, a closed plane shape. Secondly, made up of straight line segments only. Then there are no curves. Yes, so all these shapes are polygons. Now, why do we say so? Looking at the first point, you say a polygon is a closed plane shape. So all these shapes are closed. They are closed. Yes, there is no spaces around them. So, and they are also made up of straight line segments only. So all these are straight lines from here to here, from this point to that point, that point, that point are straight lines. This one to straight lines, this one to straight lines. You realize that there are no curves. So we can say all these are what? Polygons. Now, let's look at some of the parts of a polygon. We can talk about its sides, we can talk about their vertices, we can talk about the angles. Now, the sides are straight lines, and we can see them clearly here. So from here to here is a straight line. From here to here is a straight line. And all these are sides. So we can see them, their sides. Yes. And we also talk about vertices or the corner points. Yes. So when we look at this shape, see this is the vertex, corner point, there's a corner point, there's a corner point, there's a corner point. The corner point, corner point, corner point. And the third property or the third part, angles formed at the corners. So realize that the corners are where the angles are located. So you see this particular one, angle here, angle there, angle here, angle here. So the corners are where the angles are formed. When you come here to you see the angles are formed at the corners. So yes, these are parts of a polygon. Now let's continue. We are going to classify polygons based on the number of sides. So in polygons, when you're calculating, the letter n, small n, plays a key role. Yes, that small n represents the number of sides of that particular polygon. So looking at this table, it gives us some polygons, their respective sides. So we all know a triangle to be a three-sided figure or shape. Yes, so that means that since the sides are 3 and is 3, so a quadrilateral, quadrilaterals, four-sided figure or four-sided shape. You can mention them. We have square, we have rectangle, we have trapezium, we have rhombus, we have parallelogram, we have kite. All these are quadrilateral and all have four sides. So since the number of sides are 4, n is 4. pentagon 5, hexagon 6, heptagon 7, octagon 8, nonagon 9. So these are the number of sides, yes, of a polygon with their respective names. So that is that. So all that I want to highlight here is that n represent the number of sides of the particular polygon we're talking about. Now we have regular and irregular polygons. So now, why do we say some polygons are regular? We say so because they have all their sides to be equal, they have all angles also to be equal. So let's take these examples are said to be regular polygons because they have their size equal, they have angles equal. So we talk about square. Yes. So let's go back and look at square. This is a square. Yes. You see, all the lines are red and in red, telling us that all these sides are equal. From here to here is equal to from here to here is equal to from here to here is equal to from here to here. So you can say this is a polygon, a regular polygon. Now let's continue. Now we come to irregular polygon. It is the opposite of regular. So that is sides are not equal, angles are also not equal. So we can talk about an example to be a rectangle. A rectangle, yes. So when we go back here, you see a rectangle. Now when we look at the shape, realize that this side is only equal to that side, and this side is also only equal to that side. This side is not equal to that side. So since some of the sides are it is not having equal sides, we say it is an irregular polygon. Now let's do what we are here for. So sum of interior angles of a polygon. So when you have a polygon like this, we can sum up the interior angles. This is interior because it is inside. Angle forms inside, forming inside that polygon. Inside, inside, inside. They are inside, they are inside, they are all inside. These angles are all inside. So interior means inside. So we have the sum of interior angles of a polygon. Yes. So if you want to find or if you want to sum up the interior angles of a polygon, it's given by this formula. Bracket open n minus 2 bracket close times 180 degrees. We have already talked about n to be number of sides of the polygon. So if we talk about a triangle, now the sum of its interior angles is equal to 180. Now it is 180 because we are going by this formula and we know that n represents the number of sides of that polygon. Here the polygon we are talking about is a triangle. And you know a triangle has 3 sides. So n is 3. So you take the 2 from the 3, multiply by 180, then you are getting 180 degrees. We know 3 minus 2 is 1. So 1 times 180 is 180. So that explains or that tells us that the sum of interior angles of a triangle is 180 degrees. Now I come to a quadrilateral, irrespective of the quadrilateral it is, whether a rectangle, a square, a trapezium, a rhombus, or what have you. They are all four-sided shapes. So n if they are four, if the sides are four, that means that n is what? 4. So if n is 4, we take it from 2. We take 2 from the 4 and multiply by 180. Now 4 minus 2 is 2. So 2 times 180 gives us 360 degrees. So that is the sum of interior angles of a quadrilateral. Now when it comes to pentagon is a 5-sided polygon. It's a 5-sided figure of shape. So since it's 5, then 5 minus 2 times 180, which is 3 times 180, gives us 540 degrees. So that is how we calculate the sum of interior angles of a polygon. So just keep this formula in your head and know that The sum of interior angle of a polygon is given by bracket open n minus 2 bracket close times 180 degrees. Now let's see some questions solution. So a typical example, we can find this in the examination. A polygon has 8 sides. Find the sum of the interior angles of the polygon. Second, the sum of the interior angles of a polygon is 1260 degrees. Find the number of sides of the polygon. So here we were given the number of sides and you have to find the sum of the interior angles. So let's solve the first one. So focus on this one. You can write it somewhere, then look at the solutions. So a polygon has 8 sides. Find the sum of the interior angles of the polygon. So we code the formula. We know the formula from here. This is the formula. Okay. Yes. So since you are talking about the sum of interior angles, this is the formula n minus 2 brackets, all in brackets, times 180 degrees. But n was given, looking at the question, has 8 sides. That means that n is what? 8. So if n is 8, wherever you see n, you put 8 there. So you're going to get 8 minus 2 times 180 degrees. You take 2 from 8, you get 6 times 180. So the sum of interior angles of that particular polygon is 1080 degrees. As simple as that. Now, let's move to the second question. The sum of the interior angles of a polygon is 1260 degrees. Find the number of sides of the polygon. So with this particular question is quite um, tricky, but all that you need to know is that the sum of the interior angle, which we calculated over here, okay, with number of sides. This one they give us the number of sides, but this one they have given us the sum of the interior angles. That means that they worked with some particular number of sides and they got this 1260 degrees. So they're only asking to find that n they used to get this 1260 degrees. That is all. So all that you are going to do is that in place of this, when you write this formula, you know that the sum of interior angle is equal to n minus 2 or in brackets times 180 degrees. All this formula should be equal to 1260 degrees, and that's the trick. They fix in some n here and they had 1260 degrees. So equate, and they are saying that the sum of the interior angle of that polygon is 1260 degrees. So which means that there was some particular n which was used, and that's what they want you to find. So if they have given the sum of interior angle to be 1260, then you equate that to the formula, which is the sum of interior formula. Then calculate n, which is the number of sides. So 1260 degrees is equal to n minus 2 or in brackets times 180 degrees. Then you expand this one. Since we have a bracket here, this 180 will come and multiply n, which is positive, and get 180n, which is positive. But since here is minus, when 180 multiplies negative 2, you get minus 360. Yes. So since we want to make n the subject, the term with the n will be at one side. Yes. Then the one without the variables will move to the other side. It is more or less like adding 360 to both sides. You add 360 to this side, then add 360 to this side. Or in other words, like for simplicity's sake, you move this minus 360 to the other side. Since you are crossing it here, it becomes positive. But in actual sense, what we are doing is that we are adding 360 to this side and we are adding 360 to that side. So when you add 360 to this side will go to 0. Then you add 360 to that side, you get 180n here. So 1260 is equal to 180n. You divide through by 180 here by 180 here to by 180. Then 180 will go into 1629 times. So the number of sides of that particular polygon is 9. So this is how it is solved. This is the first video. In the subsequent videos, I'll be explaining um, how to find each interior angle of a polygon and the rest.